January 24th, 1944. Ford's River Rouge plant, Detroit. German intelligence agent Erich Müller stares at a clipboard that will shatter everything the Wehrmacht believes about precision manufacturing. Around him, the massive assembly hall thunders with the sound of America's most closely guarded industrial secret. Every 63 minutes, another Sherman tank rolls off the production line. Not handcrafted by master technicians like German Panzers. Not individually fitted and precision machined to tolerances measured in fractions of millimeters. These tanks are being built like automobiles, by workers who learned their jobs in 2 weeks. Using parts stamped from identical dies in 11 different factories across America. Mueller counts the components flowing past on endless conveyor belts. Transmissions, drive sprockets, track assemblies. Every single piece interchangeable with every other Sherman of the same variant. 29,947 individual parts per tank, all built to work together perfectly without a single master craftsman touching them. In Germany, this would be impossible. Krupp's finest engineers insisted that military precision required individual hand fitting. That mass production meant inferior quality. That Americans were simply inflating their numbers with propaganda. But here, in the heart of American industry, Mueller witnesses something that German engineering doctrine says cannot exist. A factory producing more tanks in 1 month than Germany's finest facilities build in 3. The morning mist clung to the Ukrainian steppes as Hauptmann Klaus Weber adjusted his periscope for the 3rd time in 10 minutes. October 15, 1943. His Panzer IV sat hull down behind a low ridge 3 kilometers east of Kremenchug, part of the defensive line that was supposed to halt the Soviet autumn offensive. Weber had commanded this same tank for 18 months, knew every vibration of her Maybach engine, every quirk of her transmission. His crew of 4 had worked together since the Kursk offensive. Professional soldiers who could load and fire their 75mm gun in under 20 seconds. Through the optical sight, Weber watched the tree line 800 meters to his front. Soviet infantry had been probing their positions since dawn, but intelligence reported no significant armor concentration in this sector. The radio crackled with routine position reports from other Panzer commanders spread across the defensive line. Weber made his own report to battalion headquarters, confirming his field of fire was clear and ammunition was full. Standard procedure for what appeared to be another quiet morning on the Eastern Front. Then the first tank crested the ridge. Weber's gunner, Obergefreiter Hoffmann, was already traversing the turret before Weber could give the command. The familiar silhouette of a T-34 emerged from the morning shadows, its sloped armor and distinctive turret unmistakable at this range. Weber had destroyed dozens of Soviet tanks over the past year. This should be routine. Range 800 meters, armor-piercing round loaded. Perfect killing distance for their long-barreled gun. But something was wrong. The white star painted on the turret side was not Soviet. American Lend-Lease markings. Weber had encountered a few Sherman tanks mixed in with Soviet formations, but this was unusual. The Americans were supposed to be shipping mostly supplies and aircraft to the Eastern Front, not main battle tanks in significant numbers. Weber keyed his radio to report the sighting to headquarters, but another tank appeared before he could transmit. Then another. Mein Gott, Weber whispered, counting through his periscope. 5 tanks, 7, 10. All bearing American markings, all advancing in a disciplined line formation that spoke of experienced crews and adequate training. This was not the desperate assault of poorly equipped Soviet conscripts. These tank crews knew their business. Weber's radio erupted with reports from other positions. Feldwebel Kruger's Panzer, positioned 2 kilometers to the south, reported contact with 8 American tanks approaching his sector. Lieutenant Fischer, covering the northern approach, counted 12 more Sherman tanks advancing through the valley. Weber did his own count again. 15 tanks visible in his sector alone. Still coming over the ridge? The mathematics were becoming impossible. German intelligence estimated total American tank production at perhaps 400 vehicles per month. Most of those were supposed to be supporting operations in Italy or preparing for the rumored invasion of Western Europe. The number of Sherman tanks appearing on the Eastern Front in recent months simply did not match the production estimates. Weber had filed 3 separate reports documenting encounters with American-built tanks, but headquarters insisted these were isolated incidents blown out of proportion by battlefield confusion. Weber gave the fire command. Hoffman's gun roared, the 75mm armor-piercing round striking the lead Sherman at center mass. The American tank shuddered, smoke pouring from its engine deck, and ground to a halt. 1 down. But 2 more Shermans immediately moved to flank the disabled vehicle, maintaining their advance. Weber's loader, Gefreiter Muller, already had another round chambered. 23 seconds. Textbook reload time. The second shot struck home as well. Another Sherman brewing up in a cloud of black smoke. But for every American tank destroyed, more kept appearing. Weber counted 21 visible targets now, with additional movement on the horizon suggesting even more were approaching. His radio carried increasingly desperate reports from neighboring positions. Kruger's voice, normally calm and professional, carried an edge of panic as he reported being surrounded by American armor. Fisher's transmission cut off mid-sentence, his radio going dead. Weber's crew continued their deadly work. 3rd shot, 4th. Each round found its mark with the precision that German gunnery training demanded, but the tactical situation was deteriorating rapidly. American tanks were breaking through the defensive line in multiple locations, their sheer numbers overwhelming the scattered German positions despite suffering heavy losses. Weber could see muzzle flashes from at least 6 Sherman guns now firing at his position. High explosive rounds impacting around his hull and showering the Panzer IV with steel fragments. The ammunition situation was becoming critical. Weber's tank carried 87 rounds of main gun ammunition, considered adequate for extended combat operations. But they had already fired 19 rounds and American tanks kept advancing. Weber made a quick calculation based on his hit rate and the number of visible targets. Even if every remaining shot destroyed an enemy tank, they would run out of ammunition before eliminating half the American force approaching their position. Weber keyed his radio for what he knew would be his final transmission. Headquarters, this is Wolf 2. American armor strength far exceeds intelligence estimates. Request immediate artillery support and armored reserves. The response came back within seconds. No artillery available. No reserves. All units were reporting similar contact with overwhelming American tank formations across the entire front. As Weber prepared to give the order to withdraw, he watched 3 more Sherman tanks crest the ridge. His after-action report, filed 12 hours later from a casualty collection point 20 kilometers behind the original defensive line, would contain one sentence that haunted him for the remainder of the war. "We cannot destroy them faster than they arrive." The roar of rivet guns echoed through the massive assembly halls of the Krupp Works in Essen as Meister Johann Richter made his morning inspection of hull number 412, November 8, 1943. Each Panzer IV required his personal attention at 17 separate stages of construction, from the initial armor plate, cutting, to the final mechanical systems integration. Richter had supervised tank production for 12 years, rising through the ranks of skilled craftsmen who took pride in building the finest armored vehicles in the world. Richter adjusted his precision calipers and checked the tolerance on the main gun mount. 0.07 millimeters deviation from specification. Acceptable, but barely. He made a note for the machinist to adjust his equipment before continuing with the next hull. German tanks were not mere machines. They were expressions of engineering excellence that had made the Reich's industrial reputation. Every component was manufactured to tolerances that would be considered excessive in civilian applications. But Richter knew that soldiers' lives depended on this precision. The statistics told the story of German craftsmanship. Each Panzer IV hull required 72 hours of skilled fabrication time, not including the additional 40 hours needed for turret assembly and final systems integration. The transmission alone contained 550 individual components, each machined to exact specifications and hand-fitted by master mechanics who had served apprenticeships lasting 4 years. No shortcuts were permitted. No compromises with quality were tolerated. Richter walked through the factory floor observing his team of craftsmen at work. Heinrich Weber, a journeyman welder with 15 years' experience, was laying perfect beads along the sponson armor joints. Each weld would be x-rayed for internal defects before the hull was approved for further assembly. Franz Müller, the transmission specialist, was hand-lapping gear teeth to ensure silent operation and maximum durability. These were not assembly line workers performing repetitive tasks. They were skilled artisans whose knowledge and experience could not be replaced by industrial processes. The monthly production numbers reflected this commitment to quality. Krupp had completed 38 Panzer IV tanks in October, each representing 55,000 man-hours of skilled labor. The new Panther tanks required even more attention to detail with their sophisticated interleaved road wheel suspension and complex final drive systems. Richter's team could complete perhaps 12 Panthers per month, but each vehicle that rolled out of the factory represented the pinnacle of German engineering achievement. A delegation of visiting officers arrived for the scheduled factory tour, led by Oberst Friedrich Paulus from the Ministry of Armaments. Richter had conducted dozens of these inspections over the years, proudly explaining the meticulous processes that ensured German tank superiority. He began with his standard presentation, demonstrating the precision machining techniques used for critical components. Precision cannot be rushed, Richter explained, holding up a transmission gear that had been machined to tolerances measured in hundredths of millimeters. A tank is not an automobile. Every component must be perfect, or soldiers die. This gear will operate reliably for 5,000 kilometers of combat conditions because we have eliminated every possible source of failure through proper manufacturing techniques. The visiting officers nodded approvingly, but Richter noticed Oberst Paulus seemed distracted. Recent intelligence reports from the front lines had been troubling. German tank crews were reporting encounters with American Sherman tanks in numbers that seemed to exceed realistic production estimates. If the Americans were truly manufacturing tanks in the quantities suggested by field reports, their industrial methods must be fundamentally different from German practices. Paulus interrupted Richter's presentation with a direct question. Meister Richter, in your expert opinion, would it be possible to increase our production rate by adopting some form of assembly line manufacturing? The Americans appear to be producing significant numbers of tanks using such methods. Richter bristled at the suggestion. Assembly line production meant standardized components, automated processes, and workers with minimal training performing simple repetitive tasks. Such methods might work for civilian automobiles, but military equipment required the precision and attention to detail that only skilled craftsmen could provide. Respectfully, Herr Oberst, mass production techniques are incompatible with military precision requirements. American tanks may appear impressive in quantity, but German intelligence has confirmed that their armor quality is inferior and their mechanical reliability is poor. They are building tanks the way Ford builds automobiles, and the results speak for themselves. The statistics supported Richter's position. German Panzer IV tanks had demonstrated superior combat performance in head-to-head engagements throughout the war. Their 75mm guns could penetrate Sherman armor at ranges exceeding 2,000 meters, while American tanks required close range engagements of 400 meters or less for effective penetration of German armor. The Panther tank represented an even greater technological advantage with armor protection that was virtually invulnerable to American guns at normal combat ranges. But the disturbing reports continued to accumulate. Intelligence estimates suggested American tank production had reached impossible levels. British Lend-Lease shipments to the Soviet Union reportedly included over 3,000 Sherman tanks in the first 6 months of 1943. Pacific theater operations were consuming hundreds of additional American tanks monthly. The mathematics simply did not work if American production capacity was limited by the same precision manufacturing constraints that governed German operations. Richter dismissed these concerns as he guided the visiting officers through the final assembly area. Here, completed Panzer IV tanks underwent comprehensive testing procedures that verified every system was functioning within specifications. Engine performance was measured using precision dynamometers. Gun accuracy was tested using standardized targets at measured ranges. Transmission efficiency was verified through controlled acceleration trials. No tank left the Krupp works until it had met every performance criterion established by German engineering standards. The monthly totals were displayed on a production board near the factory entrance. 8,400 tanks and assault guns produced by all German manufacturers in 1943. Each vehicle represented the finest military engineering in the world, built by craftsmen whose skills had been developed over decades of experience. Richter was proud that his factory contributed to maintaining German technological superiority over any potential enemy. As the visiting officers departed, Richter returned to his inspection duties. Hull number 413 required his attention, and 17 separate quality control checkpoints awaited his approval. Precision manufacturing could not be rushed, regardless of what intelligence reports suggested about American production methods. Oberst Rudolf Christoph spread the intelligence reports across his desk in the basement offices of Fremde Heere West, the Wehrmacht's Foreign Intelligence Service. December 3rd, 1943. The accumulation of battlefield data from the Eastern Front painted a picture that challenged every assumption about American industrial capability. Weber's after-action report lay at the center of the collection, its stark conclusion underlined in red ink. We cannot destroy them faster than they arrive. Christoph had spent his career analyzing enemy capabilities, cross-referencing agent reports with captured documents and prisoner interrogations to build accurate assessments of opposing forces. His methodical approach had earned him respect within the intelligence community, but the American tank production estimates defied logical analysis. German intelligence had consistently assessed American monthly tank output at approximately 400 vehicles, a figure based on pre-war industrial surveys and captured planning documents from early Lend-Lease negotiations. The battlefield evidence suggested something entirely different. Soviet tank formations now included American Sherman tanks in numbers that exceeded German estimates of total American production. British forces in Italy were operating hundreds of Shermans simultaneously. Pacific Theater Intelligence reported American armored units equipped exclusively with domestically produced tanks. The mathematics were impossible unless German intelligence had fundamentally misunderstood American manufacturing capabilities. Christoph activated Operation Bernhard's American Industrial Surveillance Network, a collection of intelligence assets developed over 2 years of careful recruitment and placement. The centerpiece of this network was Erich Muller, a German-American engineer whose family connections in the fatherland had made him vulnerable to recruitment during his 1943 visit to Berlin. Muller's employment at Ford's Willow Run bomber plant provided access to American industrial facilities, but more importantly, his engineering background allowed him to understand and report on manufacturing techniques that pure intelligence operatives might miss. Muller's first detailed report arrived via encrypted radio transmission on December the 18th. The contents were shocking enough that Christoph requested confirmation through alternative channels before accepting the intelligence as accurate. Ford's Willow Run facility was producing one B-24 Liberator bomber every 63 minutes using assembly line techniques adapted from automobile manufacturing. The same standardized production methods were being applied to Sherman tank production at Ford's River Rouge plant with equally dramatic results. The American approach contradicted everything German engineering understood about precision manufacturing. Muller reported that Ford's Sherman production used identical blueprints across multiple manufacturing facilities, allowing components produced in Detroit to fit perfectly into tanks assembled in Illinois or California. This level of standardization required manufacturing tolerances that German engineers considered impossible to achieve without individual hand fitting of components. Muller's access to Ford's engineering documentation revealed the scope of American standardization. Each Sherman tank contained exactly 29,947 individual components, every single part manufactured to specifications that ensured complete interchangeability with identical parts from any other supplier. The transmission system alone, which German manufacturers considered the most complex mechanical assembly in a tank, was being mass-produced using stamped components and automated assembly techniques. Christoph requested additional intelligence on American quality control procedures, expecting to find evidence of the mechanical failures that German engineers predicted would result from mass production techniques. Muller's response challenged these assumptions as well. American engineers had solved the precision problem through statistical quality control rather than individual component perfection. Instead of machining each part to German tolerances of 0.1 millimeters, American manufacturers accepted tolerances of 0.5 millimeters while ensuring that all components within those tolerances would function together reliably. The production numbers began to make sense through this lens of standardized manufacturing. Muller reported that 11 different factories were simultaneously producing Sherman tanks using identical specifications. Monthly output from Ford's River Rouge facility alone reached 267 M4A3 Sherman tanks in January 1944. Assembly time for a complete tank had been reduced to 8 hours through the use of specialized tooling, and workers trained for specific repetitive tasks rather than comprehensive mechanical knowledge. Christoph compared these figures with German production statistics. The entire Reich's tank manufacturing capacity, including facilities operated by Krupp, MAN, Daimler-Benz, and other major manufacturers, produced fewer tanks monthly than Ford's single River Rouge plant. American industrial capacity was not merely larger than German estimates suggested. It operated on fundamentally different principles that achieved superior results through systematic approaches rather than individual craftsmanship. Muller's reports included detailed analysis of American worker training programs that further challenged German assumptions. 60% of Ford's Sherman tank assembly workers were classified as unskilled laborers who had received only 2 to 3 weeks of specialized training for their specific assembly tasks. These workers were performing manufacturing operations that German factories reserved for journeymen with years of apprenticeship training. The American system achieved precision through engineered processes rather than worker skill, allowing rapid expansion of production capacity without the lengthy training periods required by German manufacturing methods. The replacement and maintenance implications were equally significant. Muller documented that Sherman tank transmissions could be removed and replaced with identical units from inventory in 45 minutes using standard tools and procedures accessible to field maintenance personnel. German Panzer IV transmissions required workshop facilities and specialized equipment for repairs that typically took 3 to 4 days to complete. American tanks were designed for rapid component replacement rather than field repair, a philosophy that assumed reliable supply chains and abundant spare parts inventory. Christoph began preparing his comprehensive assessment of American tank production capabilities, knowing that his conclusions would be unwelcome at the highest levels of German command. The evidence was overwhelming that American industry had achieved production rates that exceeded German capabilities by factors of 3 to 4 times through manufacturing techniques that German engineers had dismissed as incompatible with military precision requirements. The implications for continued German resistance were profound, but Christoph's duty required accurate intelligence reporting regardless of its political palatability. The final piece of Muller's intelligence arrived in early January 1944, confirming Christoph's worst fears about American industrial capacity. Ford's production methods were being replicated at facilities across the United States, creating a manufacturing network capable of producing tanks faster than German forces could destroy them. The war of attrition had already been lost. German leadership simply had not yet acknowledged the mathematical reality of American industrial supremacy. Erich Muller adjusted his safety glasses and walked through the thunderous assembly hall of Ford's River Rouge plant, carrying a clipboard that contained blueprints he was not supposed to possess. January 24, 1944. His position as a liaison engineer between Ford's automotive and military production divisions provided access to manufacturing documentation that German intelligence had requested with increasing urgency. The noise was overwhelming. Pneumatic tools, conveyor systems, and the constant movement of components through the assembly process created an industrial symphony unlike anything in German manufacturing facilities. Muller had grown up in Detroit's German-American community, earned his engineering degree from the University of Michigan, and worked at Ford for 8 years before his family obligations required a return to Berlin in late 1943. His recruitment by German intelligence had been inevitable given his unique combination of technical knowledge and family connections in the fatherland. But Muller found himself genuinely fascinated by American industrial methods regardless of his reporting obligations. The Sherman tank assembly line stretched for nearly half a mile through the converted automotive manufacturing space. Muller watched workers installing transmissions using overhead cranes and standardized mounting fixtures that eliminated the need for precision hand fitting. Each transmission was identical to every other unit of the same type, manufactured to specifications that ensured complete interchangeability without individual adjustment or modification. German engineering doctrine insisted this level of standardization was impossible for complex mechanical systems. Yet Muller observed the process functioning flawlessly with workers who had received minimal specialized training. Muller gained access to Ford's complete Sherman tank documentation through his official duties coordinating between automotive and military production schedules. The scope of American standardization exceeded anything German intelligence had imagined. Every M4 Sherman tank, regardless of which factory produced it, contained exactly 29,947 individual components manufactured to identical specifications. The blueprint system allowed parts produced in Detroit to fit perfectly into tanks assembled in Chicago, Cleveland, or any of the 11 facilities producing Sherman variants. The engineering philosophy behind this standardization challenged fundamental German assumptions about precision manufacturing. Muller examined transmission blueprints that specified acceptable tolerances of 0.5 millimeters for most components, tolerances that German engineers would consider defective. Yet American engineers had designed the entire mechanical system to function reliably within these broader tolerances, achieving durability through systematic engineering rather than individual component perfection. Muller documented the production statistics that demonstrated the effectiveness of American methods. Ford's River Rouge plant alone was producing 267 M4A3 Sherman tanks monthly, with each vehicle requiring only 8 hours of final assembly time. The American system had reduced tank manufacturing to a series of standardized procedures that could be performed by workers with minimal specialized training, contrasting sharply with German requirements for skilled craftsmen, with years of apprenticeship experience. The supply chain implications were equally revolutionary. Muller discovered that Ford maintained contracts with over 300 separate suppliers who produced Sherman tank components to identical specifications. Transmission gears manufactured in Ohio were interchangeable with identical parts produced in Michigan or Illinois. Final drive assemblies from different suppliers could be randomly installed in any Sherman tank without modification or adjustment. This distributed production network provided resilience against bombing attacks while enabling rapid scaling of manufacturing capacity. Muller's most significant discovery came through access to Ford's quality control documentation. American engineers had solved the precision manufacturing problem through statistical methods rather than individual component inspection. Instead of examining every part for conformance to tight tolerances, American factories used statistical sampling to ensure that production processes remained within acceptable parameters. Components that fell within the specified tolerance range were guaranteed to function properly when assembled, eliminating the need for skilled craftsmen to hand-fit individual parts. The maintenance and replacement philosophy reflected this systematic approach to engineering design. Muller examined field service manuals that specified standard procedures for removing and replacing major tank components using basic tools and equipment available to frontline maintenance units. Sherman tank engines could be replaced in 2 hours using standardized mounting points and connection interfaces. Transmissions were designed as complete replacement units rather than repairable assemblies, allowing field personnel to exchange defective units for rebuilt components from depot-level supply systems. Muller compared these procedures with his knowledge of German tank maintenance requirements. Panzer IV engines required specialized lifting equipment and skilled mechanics for removal and installation procedures that typically took several days to complete. German tanks were designed for longevity and field repair rather than rapid component replacement, a philosophy that assumed limited spare parts availability and highly trained maintenance personnel. The documentation revealed additional aspects of American industrial integration that impressed Muller despite his loyalty to the fatherland. Ford Sherman production utilized machine tools and manufacturing equipment that had been converted from civilian automobile production with minimal modification. The same stamping presses that produced car body panels were manufacturing tank hull components. Engine assembly lines that built civilian V8 motors were producing tank engines using identical procedures and quality control methods. Muller began understanding how American industry had achieved production rates that German intelligence considered impossible. The standardization of components, processes, and procedures allowed rapid conversion of existing manufacturing capacity to military production. Automobile plants could begin producing tank components within weeks rather than the months or years required to build specialized military manufacturing facilities. This flexibility gave American industry enormous advantages in scaling production to meet wartime demands. The final revelation came through Muller's examination of Ford's expansion plans for 1944. The company was preparing to increase Sherman tank production to over 400 vehicles monthly while simultaneously expanding B-24 bomber production and maintaining civilian automobile manufacturing for essential transportation needs. American industrial capacity was not limited by manufacturing techniques or worker skills. It was constrained only by raw materials availability and strategic production priorities. Mueller encrypted his findings for transmission to Berlin, knowing that his report would challenge every assumption German leadership held about American industrial capabilities. The evidence was undeniable that American manufacturing methods had achieved superior results through systematic approaches that German engineers had dismissed as incompatible with military precision requirements. The implications for continued German resistance were profound, but Mueller's duty required accurate intelligence reporting regardless of its strategic consequences for the war effort. The conference room in the Berlin War Ministry fell silent as Oberst Rudolf Christoph concluded his presentation to the assembled High Command. February 18, 1944. General der Panzertruppe Heinz Guderian sat at the head of the polished oak table, his fingers drumming impatiently against the leather portfolio containing Christoph's comprehensive intelligence assessment of American tank production capabilities. The other officers present, representatives from the Army General Staff, the Ministry of Armaments, and various technical departments, maintained carefully neutral expressions that revealed nothing of their thoughts regarding Christoph's devastating conclusions. Christoph had spent 3 weeks preparing this briefing, cross-referencing Mueller's field intelligence with captured documents, prisoner interrogations, and photographic reconnaissance of American industrial facilities. The evidence was overwhelming that German intelligence had fundamentally misunderstood American manufacturing capabilities, but presenting this conclusion to military leadership required careful documentation and diplomatic phrasing. The implications challenged not merely tactical assessments, but the entire strategic foundation upon which German resistance was predicated. The numbers spoke for themselves with mathematical certainty that could not be dismissed through wishful thinking or ideological conviction. German total tank and assault gun production for 1944 was projected at 8,400 vehicles, representing the maximum output achievable by the Reich's most skilled manufacturers operating at full capacity. American Sherman tank production alone would exceed 28,800 vehicles in the same period, supported by an additional industrial network producing tank destroyers, self-propelled artillery, and specialized armored vehicles in quantities that dwarfed German capabilities. Soviet production statistics compiled from intelligence sources and captured factory records revealed an additional 28,900 T-34 tanks expected in 1944, many produced using American-supplied machine tools and manufacturing equipment provided through Lend-Lease agreements. The combined Allied armored vehicle production represented a 4.4 to 1 numerical advantage that would be sustained indefinitely through industrial capacity that exceeded German resources by orders of magnitude. Guderian interrupted Christoph's statistical presentation with a dismissive gesture. These figures represent American propaganda designed to discourage German resistance through exaggerated production claims. No industrial power can manufacture precision military equipment using automobile assembly techniques. Our intelligence services have been deceived by deliberate misinformation campaigns designed to inflate enemy capabilities beyond realistic assessments. Christoph had anticipated this response and prepared documentation to support his conclusions. Mueller's intelligence reports included photographs of Ford's Sherman production lines, technical specifications for American manufacturing equipment, and detailed analysis of component standardization procedures that enabled the production rates German leadership found incredible. The evidence demonstrated that American engineers had solved precision manufacturing problems through systematic design approaches rather than individual craftsmanship, achieving superior results through methods that German industrial doctrine considered impossible. The strategic implications extended beyond mere production statistics to encompass fundamental questions about German military strategy and resource allocation. Christoph presented battlefield analysis demonstrating that German tank crews were regularly encountering numerical odds of 3 to 1 or higher in major engagements. Individual German tanks maintained technical superiority in armor protection and firepower, but these advantages were being neutralized by overwhelming numerical disadvantages that would only increase as American production reached full capacity. General Oberst Franz Halder, representing the Army General Staff, questioned the reliability of intelligence sources providing these assessments. German agents operating in American industrial facilities were necessarily limited in number and access, making comprehensive evaluation of enemy capabilities difficult to achieve with complete confidence. The possibility existed that American production figures represented deliberate deception operations designed to influence German strategic planning through the dissemination of false information. Christoph acknowledged the limitations of intelligence collection while defending the accuracy of his sources and methodology. Mueller's reports had been corroborated through multiple independent channels, including prisoner interrogations, captured documents, and photographic reconnaissance that confirmed the existence of massive American industrial facilities dedicated to military production. The consistency of evidence from diverse sources supported conclusions about American manufacturing capabilities that could not be dismissed as propaganda or deception. The philosophical challenge posed by American industrial methods proved more difficult to address than statistical arguments about production capacity. German engineering excellence was built upon traditions of craftsmanship and precision that had established the Reich's reputation for superior manufactured goods throughout the pre-war period. The concept that mass production techniques could achieve military effectiveness superior to individual craftsmanship contradicted fundamental assumptions about quality, durability, and performance that formed the foundation of German industrial pride. Guderian articulated this resistance to American manufacturing philosophy with characteristic directness. A single Panther tank can defeat 3 Sherman tanks in direct combat engagement. German engineering superiority compensates for numerical disadvantages through superior individual performance. Our manufacturing methods produce weapons that American mass production techniques cannot match in combat effectiveness or mechanical reliability. Christoph's response carried the weight of accumulated battlefield evidence that contradicted comfortable assumptions about German technical superiority. Recent intelligence from Normandy indicated Allied forces were deploying over 2,000 tanks in preparation for the anticipated invasion. Predominantly Sherman tanks supported by specialized armored vehicles produced using American industrial methods. German defensive capabilities in Western Europe included fewer than 400 operational tanks total, distributed across the entire Atlantic Wall fortification system. The Eastern Front situation was equally dispiriting from a strategic perspective. Soviet armored formations had grown to include over 6,000 tanks, with approximately 1,200 American-supplied Sherman tanks providing mechanical reliability and standardized maintenance procedures that enhanced operational effectiveness. German tank strength on the Eastern Front had declined to fewer than 800 operational vehicles, many requiring major maintenance or component replacement that German supply systems could not adequately support. Christoph concluded his presentation with an assessment that he knew would be rejected by military leadership despite its mathematical accuracy. American industrial standardization had achieved production rates that would enable sustained combat operations at levels German manufacturing could not match. The war of attrition was already decided. German resistance could delay but not prevent eventual defeat through overwhelming material disadvantage. The silence that followed Christoph's conclusion lasted nearly 2 minutes before Guderian dismissed the briefing with instructions that the intelligence assessment remain classified at the highest security level. Official doctrine would continue to emphasize German technical superiority and the temporary nature of American numerical advantages. Christoph gathered his documents knowing that his accurate analysis would be ignored in favor of politically acceptable assessments that supported continued resistance despite hopeless strategic circumstances.